This conference will now be recorded.
Yep.
Good afternoon, everyone. I am Rachni Jain on behalf of agricultureinformation.com. I'd like to welcome you all to this online meeting. Please take a moment to review the guidelines for this online meeting posted in the chat window. I now request the moderator, Mr. Lakshmipati, to introduce the speaker and start the meeting. Thank you.
Thank you, Ms. Rajani. Good afternoon, everyone. I am Lakshmipati. I'll be moderating this meeting. Agricultureinformation.com likes to welcome to this meeting Mr. V Chandra Mohan, founder CEO of Acclaim Technology Services India Private Limited, Chennai, Tamil Nadu. Mr. Chandra Mohan will be speaking on the topic process of generating biogas from fruit and vegetable waste. I now request the speaker to begin.
Good afternoon, everyone.
Good afternoon.
Thanks to Mr. Lakshpati and the Agricultural Information for asking me to make this presentation, and I'm really thankful for the opportunity given to me.
You're welcome, sir.
We will straight away dive into the presentation that we have. And I mean, what would you like to have? Would you like to have the questions even as you see the slide or at the end of the meeting?
No, at the end of the session, your talk session, then we'll have question round, sir.
Excellent, right. Okay. So let's get into it directly. So Acclaim Technologies, we have been in the renewable energy business for the last 20 years. We started off as a biomass power plant that is based on gasification, okay, as different from biogas, meaning that is a thermochemical process, okay, and this is more of a microorganism based process, biochemical process. So now let's go directly into the biogas plants. We've been making biogas plants in tie-up with the BARC, whose technology we adopted initially, and right now we have made some slight modifications to the technology, but we still associate ourselves with BARC. Okay. Now, the biogas plant is a microorganism based. See, we have all come across this. You have seen, anybody who is in this thing, biogas, gobar gas is something that we have been started off with, let's say about 20 years ago or 30 years ago. A lot of gobar gas plants were put up. The process is very, very, very similar to that. Okay. So let me go to the okay. Now, biogas can be made from a lot of inputs, kitchen waste, food waste, plant waste, that is agricultural waste, animal waste, and all these things. So you will go, on these one by one. So, this is something we would like to say. Initially, it was Stone Age, Bronze Age, and now garbage. Okay, we brought this up for the simple reason. Biogas can also be made from organic part of the municipal solid waste, garbage. Okay, dump yards are the main cause of pollution, especially the organic part. Okay, the other parts can be recycled. So what we do is we can always convert this also to biogas. Typically, we will go by three types of waste: biodegradable waste, non-biodegradable waste, and non-combustible material. That is neither, in the non-biodegradable part, there is a combustible part and there is a non-combustible part. So actually, our as discussion will center only around this part, the biodegradable part. Okay, we are not so much concerned about the non-biodegradable version at this part. For this particular presentation, we are not concerned about the non-biodegradable part. When it comes to biodegradable, most organic materials degrade over time. Some things degrade faster and some things don't degrade as fast as that. Okay, so for instance, typically materials like fibrous materials, okay, like coconut, fiber, or drumstick fiber, or fiber of banana leaves. These all take a little longer to degenerate compared to the other material like food waste, cooked food waste, or vegetable waste, and things like that. So strictly speaking, it is not a question of time, but I mean, although the discussion will be on the fast degradable material, and we will try to avoid things that degrade over a longer period of time, like what I just mentioned to you. So the idea of is we want to convert. See, today India is a huge importer of fuel, especially the fossil fuel, and it is also a huge outgo of foreign exchange because of that. So the idea is to convert whatever is possible to be converted into fuel, at the same time also minimizing the environmental impact, which is the most important part of these gases. For instance, if these materials which we are trying to convert to biogas are left in the open, the same methane that we are converting here will also occur in nature. Okay, and for your information, methane is 20 to 21 times more harmful to the atmosphere compared to carbon dioxide. So what we are in effect doing is, we are strictly speaking minimizing the impact on the environment, and at the same time converting it to a fuel, and also reducing the CO2 that would otherwise be emitted by using fossil fuels for the same application. So what is biodegradable waste? Something that can be broken down into base compounds like carbon, hydrogen, and oxygen by microorganisms and other living things. So this is what we really are looking for when we say biodegradable waste. Things can be degradable by microorganisms. So I mentioned to you what is fast degrading and what is slow degrading. Food waste generally remains a balanced cook. You cook in your kitchen some of the food that the vegetable peels and some excess rice kanji or excess rice, or these are all things that are part of your day-to-day life. It may be large, it may be large in volume or less in volume, but there will always be some quantity of some food that get left over in your day-to-day life, in your house, or in maybe in canteen, or it may be in hotels. So this is one important input. Although we are not concerned about this, we are coming only to the agricultural part. So this is one of the things that is one input for the biogas plants. Similarly, water waste, washing of vegetables, grains, when you remove, then the plate wash, the hand wash, and also, water waste that comes out of your toilets, if it is not contaminated with your cleaning liquids, that again can be an important source. The what we call biomethanation of night soil. Okay, this is another important input in the raw material for our biogas production. Then animal waste. This is again a very important. I probably may be a part of the agricultural part, although animal husbandry we still believe is part of the agricultural heading. So cow dung and chicken litter, fish litter, especially cow dung and chicken litter, also constitute a very, very important input in converting to biogas. There are already plants, gobar gas, of course, we have all heard of. Chicken litter has also been converted and very efficiently into biogas, and quite a few plants are operational now, even in Tamil Nadu, especially in and about Namakkal area where chicken is grown in abundance. Like they are the among the largest chicken egg producers in the country today. Okay, so those areas, chicken litter has already been converted to biogas. Cow dung has always been converted to biogas. So this is one important agricultural waste that can be an input for conversion to biogas using biomethanation process. Okay. Human waste. I mentioned to you, stools, urine. These are all chemical-free. Flushing should be ensured. So as I mentioned to you, if it is not contaminated, you're going by the good old practice of having a septic tank with no chemical inputs for the cleaning, that would be an ideal method for conversion to biogas. These are slightly agri-waste relatively, are slower degradable when it compared to the food waste and the animal waste. Okay, so vegetable and fruit waste, strictly speaking, are borderline, meaning they are not really very slow, but they are also reasonably fast, but not as fast as the animal waste. Like cow dung, for instance, is highly easily biodegradable compared to, let us say, vegetable or fruit waste. So, but vegetable and fruit waste are a very important component in today's lifestyle, and so that would also be a very important input that we should be considering in our conversion aspects. Similarly, other inputs, like people may want to know, will agricultural residue like rice straw or wheat straw or grass and garden trims can be converted to biogas? Yes, they can be converted to biogas, but when they are fresh. Imagine if grass is dried, then it may not be an ideal input for biogas conversion. Similarly, dried wood, dried twigs, they are not ideal candidates. In fact, we should not be putting them at all into the biogas plants. And today, a lot of work is being done on rice straw and paddy straw, because you must have all read in the newspapers, especially about stubble burning. People are burning the stubble in the fields, especially in and around Punjab and Haryana, so that it is causing a lot of pollution. So some work is being done to see if the stubble can also be converted to biogas to speed up the process. Okay. In fact, there is one plant that is coming up which is going to use, let us say, paddy straw in Punjab as an input. So we will have to wait and see how it performs in the actual commercial space. Similarly, waste paper can also be used, but in smaller quantities along with other input raw material, not exceeding 5%. So that can also form an input in the biomethanation process. As I mentioned to you, municipal solid waste, if it is segregated into organic and the inorganic part, then again, it can be used as a material. In fact, there are lots of plants which are operating. Even Chennai has a plant of 100 tons per day. Okay, they are not operating to full capacity now, but based on organic part of the municipal solid waste. And quite a few of these corporations are now in the process of segregating the wet waste and the dry waste, so that what you call source segregation. So if source segregation becomes highly successful, which I'm sure is going to happen in a period of time, then the scope for biomethanation of municipal solid waste is tremendous. So probably a few years from now, that will again be a very, very important source of biogas for communities. So typically what you see, the picture here is a biogas plant that is operating in Wipro. Okay, quite a few people will be wanting to know how this biogas plants will be very messy, will it be smelling, and all those things. So typically you see this picture here. This is at the entrance of the Wipro campus in Bangalore. So this is typically a process of biomethanation. Let me go over this one by one. First, the input material, whether it be fruit waste or vegetable waste, it is crushed. The crushing is to a size of about 1 to 2 mm, okay, very small pieces, so that a large surface area is available for the microorganism to act. So you are trying to speed up the process of degradation. Okay, so the first step in the biomethanation process is to convert the input or make it homogeneous as much as possible by crushing it. Okay, and the kind of crusher that you use will depend on the input raw material that you have. If it is food waste, then you will have a crusher. If it is going to be a little more of agricultural waste like grass and things like that, maybe you may want to have some kind of a tearing mechanism, shearing. So you will have a shearing kind of crusher there. Now, the process that we generally employ, if you look at the conversion to biogas, the first stage is acidogenesis, meaning there is one set of bacteria which converts the organic matter into an organic acid. Now, that can happen even in the presence of air. Then the second part, the acid, is then converted by a different set of bacteria under anaerobic conditions. Anaerobic meaning in the absence of air, to methane. Okay, so there is a two-stage process, or there are two definite steps in the process of biogas production. So to make this easier and to make the process a little more efficient, the reaction of biomass is also carried out in two stages. First, the crushed material is taken into a pre-digester, where in the pre-digester it will remain from about 3 days to 5 days depending on the raw material that you are putting in, and air is passed, a compressed air is passed into it, or it is allowed to aerate, so that the first stage of the reaction gets carried out faster under aerobic conditions. Okay, from the pre-digester the material flows to a digester. In the digester, it is totally anaerobic, meaning the material does not come into contact with the air. During this period, it is totally kept away from any contact with the atmosphere. In the digester, the material will remain for anywhere between 22 to 25 days. No, the longer it remains there, the more biodegradation will take place. It can be even 35 days or it can be 45 days. But a period of 20 to 25 days, practically most of the material, since we are not putting any slow degrading material into this, or we are trying to keep it to the minimum, the most of the materials that we put in will get completely consumed in terms of biometanated during this 22 to 25 days. So generally 21 days to 22 is recommended, but as a matter of abundant caution, we will design for about 25 days. And the biogas that comes out, okay, from this digester will contain methane anywhere from 60 to 65%, 55 to 65%, depending on what material you are putting in and the anaerobic conditions that you maintain. Meaning, if the weather is very cold, then the reaction, that is the microorganisms, do not act as fast as they would under warm conditions, because these microorganisms which convert the organic material into biogas are what we call thermophilic bacteria. Thermophilic meaning they are all operating under reasonably high temperature, meaning 50 degrees. They also they live even up to, they can even operate up to 70 degrees. Okay. So ideally, what we will do is, instead of maintaining at high temperature means putting in energy, around 35-37 degrees is the normal temperature at which the digester is maintained. Now, for some applications, okay, and now coming to the gas that comes out is stored in balloons, okay, so that it can be at different capacities. So typically it is stored in balloons and then used in any end application that you will want to use it for. Okay. So this is typically the biogas composition: 65 to 70% methane, 30 to 35% carbon dioxide. Hydrogen sulfide is another component, is something that you don't want in the biogas, but it will happen depending on what input you are putting in. And in some cases, we use it without removing H2S, but in other cases, we may have to remove the H2S. For instance, if you are going to use it only for the cooking part in stoves, in kitchens, we generally don't recommend any after treatment. We just try to store it in balloons, remove the water, and send the gas directly to your kitchen stove. So there are special stoves which are designed to operate on biogas, containing about 55-65% methane and CO2, which will give you a result, depending on your the size that you choose, as good as your LPG stove for kitchen application. Okay. In some other cases, for instance, today, there is a nationwide movement going on, especially, the oil companies have taken a lead in this, to use biogas as a transport fuel. It is called SATAT, and all the leading, the government oil companies are working towards having compressed biogas, which will be retailed in their own pumps, okay, and sold as biogas for your vehicles. Okay, today you have seen auto rickshaws running on gas, CNG. That is what the CNG. Compressed biogas and compressed natural gas are almost the same. Both contain about 90% to 97% of methane. So when I say compressed biogas contains 97% of methane, that means since the gas that is coming out of the digester contains only 60%, that means you have to literally upgrade the gas from 65% to excess of 90 to 93, up to 94, 95, even 97%. That means you will have to remove the H2S, and you will also have to remove the carbon dioxide from the biogas in the generator. So there are standard processes available, which you call pressure swing adsorption method and scrubbing the H2S to bring it to less than 20 ppm. H2S is brought to less than 20 ppm, and the methane is upgraded to 94-95% to be on par with your compressed natural gas. So this is what we call bottling of the biogas. See, the biogas, when it is bottled at very, very high pressure, because unlike LPG, which is liquefied under pressure, methane does not liquefy under pressure at normal temperatures. So we are going to compress the biogas up to 200 kg per centimeter square. That is 200 to 250 times atmospheric pressure. Okay, so it is really high pressure compression. Then the application of bioenergy for heating. You can use it in heating. You can use it in boilers. You can use it in the kitchen stoves. Then you can use it for cooking chips making, all industrial process. Any industrial process where even LPG is used, CNG is used, diesel is used, it can all be replaced with biogas, either in its natural form or compressed form, depending on the end use application. Now, drying, any drying application can use the For instance, today biogas plants are operating for coconut any drying operation can happen with the biogas. Then you can even have chilling and air conditioning with biogas. Today there are gas operated what you call absorption chillers where chilling can be done. So this is one more application for this thing. Power generation is standard, meaning there are standard engines available in even Indian engines. So 125 kVA genset can run exclusively on this biogas. Any CNG plant, any CNG engine will also run. For instance, today you must have all heard of Tata. Tatas are offering buses which run on CNG, and all those buses will also run on compressed biogas. Vehicle fuel, I was just mentioning this to you earlier. So typically buses and cars can run on CBG, compressed biogas. In fact, there are already buses operating, especially in the Scandinavian countries, in Denmark and all that. The buses are operating on CBG, compressed biogas. Public transport is run on compressed biogas in the Scandinavian countries. So any of these industries which are generating, paper industry for instance generates a lot of waste which can be converted to biogas, and they are already doing it also in some cases. Animal waste, abattoir waste. Abattoir waste is again another thing that can be converted to biogas. Fish markets waste, then vegetable market waste, then fresh fruit and garden waste can be all converted to. So, and typically you may want to know how much gas will I get. Let us assume you are putting in 1 ton or 1 ton of, let's say, vegetable waste or food waste. You can get as much as 80 to 90 cubic meter under ideal condition, 80 to 90 cubic meter of gas containing about 60% methane, 60 to 65% methane. So this is typically one thumb rule. If you are going to put in cow dung, for instance, cow dung is already pre-digested, meaning the cow has already had the agricultural input, has eaten the agricultural input, carried out the pre-digestion process in its stomach, and it is only sending the totally digested material outside. So cow dung is ideal. In fact, cow dung will form the source of our input stock, that is the bacteria for conversion. So when you want to start your biogas plant, the first thing that we do is to add cow dung to the system before we start adding the regular waste. And from time to time, if you want to improve the bacterial population in your biodigester, you can also add cow dung to improve the population of the biodigester. Okay. So we have standard mass. Most of them are specific design, but smaller like 100 kg, 200 kg, 500 kg, 1 ton plants are almost standard today for making biogas. So this, what you see in the picture here, is a typical purification process for converting, like I told you, upgrading the biogas from 60 to 65% to 90 to 95% or 96% methane. So what is happening here is the H2S is removed, it is scrubbed and removed. The CO2 is also removed. Okay, it is adsorbed and desorbed, what they call a pressure swing adsorption, where the CO2 is also removed from the gas. So the same thing, biogas purification section. Okay, this is typically. This is a 500 liter biodigester. These are all examples of bio plants. A typical layout for 100 to 100. See, this is, if you've seen, this plant is made exclusively with HDP. It's an integral plant. The pre-digester and the digester all in one part. You can see the crushing table here, the crusher here. There is a water heater. I mentioned to you the ideal temperature to operate all these, for biogas generation is about 35, 40 degrees, 35 degrees to 37 degrees. So there is a water heater that is provided, which will heat the water as it feeds so that the bacterial action can take place fast. You also have a compressor here, which is going to feed compressed air in the pre-digester so that the pre-digestion can take place earlier. And like I told you, the sorting table there, in the sorting table, generally when you are talking about waste, what happens when you put in material that does not digest? You know, when you are collecting food from the market or waste from the market or from the canteen or anything, a lot of other unwanted things will also go into the digester. For instance, let's say you are having a canteen. The canteen, what can happen is sometimes spoons, sometimes, you know, other material like, you know, eggshells and things like that can also get added. Eggshell is again something that does not degrade very fast, like drumstick fiber and then coconut shell or you know, coconut fiber. These are all things that don't digest fast. So generally what we try to do, if it's a small plant or even large plants, we try to manually remove these contaminants before we feed it into the grid. Okay, so this is typically picture. There is, you know, you can use this as I mentioned to you. There is no waste in the sense you can convert, you can put up these plants in typical markets so that the waste that is generated in the fruit and vegetable market does not go out. You can have your own biogas plants within the market itself. And as I mentioned to you, the gas can be used to have a chilling plant so that you can also have a cold store in the market itself, so the vegetables do not degrade very fast. So they are all ideal conditions. People are now working towards this to see if we can put up these plants in the market and convert the vegetable waste generated in that location into gas, and also provide a cold store so that the people who are doing selling can store it in the market. It doesn't degrade very fast, so the wastage is minimized. So this is typically the underground plant. You can have it underground, you can have it overground, so space can be minimized. So there is nothing else, meaning the process is natural. Okay, there is, once you feed the material into the pre-digester, you crush it and feed it, then there is no need for any manual intervention down the line till the gas comes out. And the what happens to the, there is also a besides the gas, you will also have, you get a digestate, meaning what is left over after digestion that is coming out, which is an ideal fertilizer. It can be liquid or solid fertilizer. So typically today the technology is proven, meaning like there are no ifs and buts about whether the gas will come, how much will come. All these things are generally, for a lot of inputs, you can tell clearly how much gas you will get. Okay, the process is very eco-friendly. Like I told you, the maintenance, it's not exactly maintenance free, but very, very low maintenance, because in case you have a compressor, or in case you have, especially when you are talking about upgrading a gas, there are some machines involved other than the digestion part, which may require some maintenance. Highly cost effective because nothing else is required. And I wouldn't say no electricity is needed, but no electricity is needed to generate the gas under normal conditions. But for crushing, if you put it in there, it will still generate gas, but we are crushing it so that the process is speeded up. So there will be minimum electricity required, minimum maintenance. It is self-sustainable. You don't need anything else. And the plants, like I told you, it's aesthetic. You can put it up, as I told you, Wipro has put it up right in front of their entrance. And nobody will even know that there is a biogas plant operating at that location. No mosquitoes, no odor, nothing. It will be very clean. So, and one, as I mentioned to you, by putting up these plants, we are reducing the global warming, or we are contributing to reduction of global warming in a very, very large way. So as Acclaim, we will give you end-to-end support from right from designing the the plant to incorporating it, erecting it, and in some cases even selling the gas if you want. So case study, this is typically the Wipro Bangalore case, plant that I told you about. This is a 500 kg per hour, which is using food from their canteen and also supplying gas to their canteen. Then this is a plant 500 kg per day in Tamil Nadu Newsprint and Papers Limited, Karur, for 500 kg using their canteen waste, again being used in the canteen itself. And this is a plant in TCS in Chennai, designed for 4 tons per day of food waste. Okay, and the biogas is used to run 55 kVA gas engine, and they are using it for street lighting. This is a small plant. This is a community of about 3,000 houses. They have got a biogas plant for 3 tons, which gas is being used in the kitchen of an old age home that they are running within their premises. And this is a very small plant, which I told you. It's a 100 kg plant. We are showing this largely for you to get an idea of what a small plant will look like. This is totally compact. It can be moved anywhere. It can be put up anywhere. It can be put up on the terrace also without any problem. Any place that you have, you can put it up. You can move it from one place to the other. And this is for a small engineering company in Pondicherry using in their canteen for 100 kg per day. So that's about it. So this is the end of our presentation. So if you have any questions now, you please, I hope we have enough time for the questions. Right, sir. Okay.
Thank you, Mr. Chandra Mohan, for an excellent and detailed presentation and talk. I now request the participants to ask their questions. We'll also be posting the speaker's contact details in the chat window. Now over to the participants for questions. The first question could be from participants. Please indicate your willingness by putting on your mics. The first question could be from Mr. Joseph Brito. You have a question, please? Mr. Brito?
Hello.
Yes, Mr. Brito.
Thank you, Mr. Lakshmipati.
Welcome. You're welcome.
Thank you, Mr. Chandra Mohan, for a very nice, detailed presentation.
Yep.
Could you tell us what is the cost of this 100 kg unit, and what will be the cost of, say, a bigger unit, the range,
See,
the time to...
see okay, now you have an option. Okay, what I have shown to you is a compact HDPE unit. Okay, in most of these cases, what we have shown you is a plastic unit. Now you can also do the same thing in civil construction. Okay, now when it comes to, and if you look at the cost breakup, the digester and the pre-digester will contribute nearly 60% of the cost. Now, ideally for small ones, if let us say you have, say Mr. Brito, you have the wherewithal of constructing the civil part yourself, because it's like just building a small, not exactly a well, a small circular storage tank for you. Okay, if you can do that, then the cost can come down significantly because you are better off. We can give you the drawings, we can give you the design. Okay, now that will depend on the location and things like that, but I'll give you a number. The 100 kg gasifier biogas plant with HDPE and all the accessories, including erection, transportation, will come to about 7 lakhs. But by the same token, if you go for 200 kg, it may not cost you 14 lakhs. It may cost you only 10 to 11 lakhs. So the viability or the cost will come down, not linearly, it will come down much better, much more as you go for higher capacities. Because see, if you look at the 100 kg plant, almost 70% of the components that we will give in a 1-ton plant, or 80% of the components that we will give in a 1-ton plant, will all be present in the 100 kg plant also. Like, the compressors will be there, the crusher will be there, the biogas balloon will be there, everything will be there. Okay, the pumps will be there. So and if you do it in your own, let us say, civil, it may be about 1.5 lakhs less.
Okay, Mr. Brito. Okay. Next question from Mr. Sudhiranjan Mandal.
Good evening, sir.
Yeah, tell me, sir.
Mohan, sir. Now, the place where it is be kept, is there any particular way it should be kept, or the construction, how it should be done?
See, actually, like I told you, the process is meaning like once you crush it and put it inside, the arrangement is such that the flow takes place from the pre-digester, one vessel to the other, to the final output of gas without any manual intervention. Okay. So, and if it's a small plant, like the plastic one, you can even put it on your terrace without any problem.
How much time will the gas last? Like you have normally in the household, you have LPG. We know that it will last for a month or so, normal consumption. Now, a 100 kg plant, for how much time it will give
Okay.
output?
Let us assume a 100 kg plant using, let us say, your food and vegetable waste. A 100 kg plant using food and vegetable waste will generate something like 8 cubic meter, anywhere between 5 and 8 cubic meter of gas, depending on what you are putting inside. Okay. Let us assume for a moment you are talking about 5 cubic meters, because I told you, gobar gas will give you only 5. If you put in food waste and things like that, it can go up to 8 or 9. So assuming you are getting 6 or 7 for argument's sake, the 6 or 7 kg is actually equal to half your, half of that value. So assuming 2 cubic meter of gas is equal to 1 kg of LPG, and your domestic LPG is about 14.2 kgs. Okay. So if you put up a 100 kg plant, which may be too high for a domestic application, but for a canteen or any such application, it means replacing 3 kgs of LPG to 4 kgs of LPG, or as much as even some rare cases 5. Let us take 4 kgs to 4.5 kgs of LPG per day.
Okay.
So that means I am talking about 8 cubic meter of gas, the 9 cubic meter of gas.
Any more questions, Mr. Sudhiranjan? Okay, let me go to Mr. Pa Madi to ask if he has got any question. Yes, Mr. Madi. And what about Mr. Mohan?
Thanks, Lakshmi Ji. Good
Yes,
afternoon.
I would like to add one more thing, which we probably missed out in the presentation. See, today, sugarcane is one of the biggest agricultural producers, especially in Tamil Nadu, Maharashtra, UP and places. Okay. And most of the sugarcane gets processed in sugar mills. And sugar mills have one very important byproduct, which they are not, they are finding it very difficult to deal with that, especially what you call press mud. Press mud is the output from the filter press that is present in the sugarcane mills. This filter press, we have already put up plants where press mud is used as an input raw material for conversion to biogas. So even though we do not use the direct agricultural input, but the byproduct of an agricultural processing can be a very important source of raw material for this. Similarly, we are working with, let us say, some companies which are making coffee waste, coffee processing waste. In fact, we are working on a coffee processing plant which is producing 100 tons per day, which is processing 100 tons per day of input. Okay, and generating about 200 to 200, roughly about 3,000 to 5,000 cubic meter of gas daily. Yeah, sorry. Now, aside from whatever we have discussed, this is something that I thought you should know.
Yes, Mr. Mohan.
Yeah. My question is, Mr. Chandra Mohan ji, if it is not only the vegetable fruits or wastes, we can try for the like chilies stem cells are there in Guntur, where actually in market yard we get tons of the wastage of spillage of the chilies and the stem part, the top part, So all those things also can be used.
As I told you, all fruit processing like pineapple processing, mango processing, they are all ideal.
Okay.
Okay. So anything that does not interfere with the life of the microorganism will all be ideal inputs for biogas generation. Okay.
Okay.
To be very honest, we have not done anything that is exclusively chili. Okay. I need to study the residue from the chili to find out what is the kind of this thing right now. But I expect it is definitely possible to make it, into convert it to biogas.
The reason is because that the season for the 4 months or 5 months from January to May, whenever the yielding time and the arrivals, lakhs of bags will be arriving to the Michiyard, because Guntur Michiyard is the world's largest producer of the Michiyard, and their Michiyard income will be around 70 to 80 crores, and they produce lot of wastage of this product what I mentioned. And when it rains, actually there is a pungent smell and those type of weird. So I thought if that can be utilized, I can discuss.
It can be. We would like to definitely work with you to find out how it can be converted. You can get in touch with us, because right now I'm not able to give you definite inputs on how much gas will come through. But yes, definitely we can work on that, especially the wet waste. You don't have to allow it to dry. See, generally what happens is the odor and all these things come up only when you allow the waste to putrefy in the open. If you do not allow, let us say you generate it and use it immediately, the putrefaction does not take place. All the microorganisms which act on this are acting on it in an enclosed space and converting it, so the odor does not get out into the atmosphere in the open. So that smell can be avoided totally. Yes, you are right. That pungency which happens in drying and putrefaction, the process of degradation can be avoided. Yes.
And it is a headache for the even town people also, and even district collector also facing a hell of the problem, because nobody knows. In the midnight, all these farmers and the traders, big traders, they will throw it on the national highway besides and residential areas, where it has become a headache for them to clean and all this waste material.
See, there is just one issue that you must consider there, because you see, when you are going to make an investment, okay, based on, see, the input material is a very crucial part in this. So assuming you are going to get 4 to 5 months of this waste, you have to literally source other raw materials which will go as inputs for the other season. For instance, chili season may not be mango season, or mango season can be. So if you are able to mix and match, for instance, somebody who's mango processing, they also take up tomato processing, they also take up guava processing. So what could otherwise happen in 3 months can get extended to 6 months also in some of these cases. So if you are able to look at something like that, then it makes the project that much more viable and easy for people to invest in that.
Because Guntur is basically we have three commercial crops. One is the chilies, and the other one is the cotton, and the third one is the tobacco. So these massive volumes they produce, and they do export, lot of exports, and all multinational company like ITC, Eastern Masala, Achi Masala, all these people, they're doing millions of rupees of turnover. Definitely we'll work out it and let's see. And my last question is, Mr. Chandra Mohan, is there any possibility of doing utilization of the sea waste, like shrimps processing waste and all those things?
See, okay, typically it is like this. We work with Tata Tea. Okay. Okay, and this Tata Tea in one of their locations in Valparai generates as much as 60 tons per day. Okay, so the question is, of course, that waste is not exactly something that it makes it viable for gas generation. One is there is not the gas generation there in the tea waste, at least from those plants, is not doesn't make it viable to install a plant. Okay, so we've already worked with Tata's on that, and we find we are not able to justify the investment for them to put up a biogas plant. That is one reason. The other reason is most of these tea gardens are located in higher elevations where the temperature does not go down, and so the microorganisms are not as effective as they would be, let us say, in a warm and climate. So you may have to provide some additional inputs to make it work, like heating up the digester or providing, even in Chennai, we are giving you, like I told you, a heater to provide hot water. So it makes it more difficult in higher elevations to provide the same, resource.
That problem won't arise in Guntur because we'll
I
have
know.
a 40-50%.
The problem will not arise in Guntur. You are correct. So we can definitely explore that possible. Like I told you, the only issue is we need to provide other inputs during the off season.
I got it. Thanks. Thank you.
Thank you. Right. Before I go to the chat window, any questions, please, from the participants? No questions. Then let me go to the chat window. There are some couple of questions over there posted by participants. Let me go. The first question from Mr. Suraj Sebastian. The leftover is liquid waste or solid waste. Can it be used as compost in agriculture?
See, liquid waste, generally, we don't recommend composting. Okay. Solid waste, liquid waste can be converted to biogas if it contains a significant organic degradable portion. Okay. Even in process, depending on the, if you are especially fruit processing or food processing waste, they generally contain a lot of, materials which can be converted to gas. Okay, and it may be viable as a solution. But the composting is generally recommended for material which are solids. Okay. So today you must have all heard of the organic portion, the municipal solid waste. The process is a little, like I told you, composting is an aerobic process. So you need to have total aeration for that. So if you want to make a composter, we also do work on composting, okay, where it may not be viable to put up, or the people cannot afford to put up a biogas plant. Composting can be done. It's a far simpler method. Okay, you have multiple methods of composting. You can have it in what you call windrows, where the material is piled up in a long row, and you can have a windrow turner, meaning that material is turned about once or twice a day so that it gets air circulation. That is one. And the second method is to have in-vessel composting, meaning you compost it in a vessel where you maintain the moisture, there you maintain the temperature, so that typically materials that would take even 40-45 days in normal conditions, that is the normal atmospheric conditions, can be composted in about 2 to 3 days.
Right. The next question from Mr. Suraj Sebastian is, can we use earthworms as digester in aerobic digestion?
See, earthworms are useful in the ground, sir, for what you call, otherwise you call vermicomposting. So it is actually a process where, see, what earthworms do is to provide aeration in the subsoil material. Okay. So it would be unwise to have earthworms. They do not. If you want to know if earthworms will contribute to biogas generation, no, not to my knowledge. But earthworms are useful in the composting process to provide aeration in the soil. So I don't think they're going to make a big difference in the biogas generation.
Right. Thank you. His next question is, I do mushroom cultivation where the leftover is mycelium and the medium is moistured dried paddy straw. Can it be used in biogas?
This is something that we have worked on in Ooty, okay, and actually, as I told you, straw is not the ideal material for biogas generation because it is fibrous and it takes a little longer for biogas production. But can it be done? Yes, it can be done. Definitely, it can be done. Okay, so again, unfortunately, the person with whom we worked has his own, what do you call this? Cultivation in Ooty near Kunur. So to convert that to biogas there was not recommended for them. But yes, in other areas it's definitely possible. We can work on that. One other solution which may not be biogas is as I mentioned to you, aside, we can even discuss that option if you are clear personally, because there could be other solutions instead of biogas generation alone. Okay, you can have that as a converted to carbon, and the carbon will give you much better input in your cultivation of mushrooms also. It can go back as your input in your bedding material or your mushroom cultivation substrate.
Okay, thank you, Mr. Chandra Mohan, for answering. Any other questions, participants, before I close? Okay, it's time to close. We have come to the end of the session. I'd like to thank the speaker, Mr. Chandra Mohan, on behalf of Agriculture Information for taking his time to speak with us. I now request the organizer of the meeting, Ms. Rajini Jain, to please close the meeting. Thank you.
Thanks, all of you. Thank you very much.
You're welcome.
Thank you, Mr. Lakshmipati. I'd like to thank the speaker, Mr. Chandra Mohan, for taking the time to talk with us. I also like to thank all the participants for their time. The meeting will now be closed.
Thanks a lot. Thank you. The pleasure is all mine.